Before we proceed with the assertion, some distance is greater persuasive to sort out what molecular gasoline petals are. The Big Hadron Collider, LHC, operated by CERN, is a 17M ring of superconducting magnets. In addition, it is the world's most prominent and most noteworthy atom smasher. It represents the pinnacle of personal happiness. In fact, it is so potent that it can replicate the exact states of the first experience on Earth. However, could the machine intended to hold the universe's mystery open the key to something truly unique? Started in 1954, CERN is one of the world's most notable research establishments, with 23 member states and countless researchers. It's an area for collaboration and innovation. The LHC is CERN's main undertaking, but it is only one part of a huge organization of fuel pedals and exams. Consider a course to be of little use, motors or humans, but for subatomic debris in a trial of flare, staying power, and space itself. The LHC accelerates protons to almost the speed of light, sending them on a collision path that reflects the energy of the universe right after the Big Bang. The impacts produce temperatures that are much higher than the center of the Sun. A massive number of protons are guided by magnets on their journey, while complex cooling systems hold the magnets at temperatures less hot than space. The beams in the LHC are designed to malfunction across 4 locations. The gas pedal ring connects with the spots of 4 particle detectors: Atlas, CMS, ALICE, and LHCb. Each fills a specific purpose, investigating different additives of particle physics. Together, they act as massive cameras, taking photos of these collisions. Scientists then sift through the particles, searching for signs of the elusive Higgs boson, also referred to as the God particle, and other anomalies that could provide clues about the universe's essential building blocks. By focusing on the microcosm, we gain insights into the universe. But with every answer comes another query, and for each and every discovery, another challenge emerges. The LHC isn't only a scientific tool, it's an exhibit of human interest and progress. It represents our entrepreneurial mission for understanding and our desire to recognize the key forces that shape our universe. However, as we push the limits of what we know, we must also bear in mind the more profound and existential questions that arise. What are the risks of probing the unknown? Could our quest for information inadvertently unleash powers we have no control over? Inside the sacred halls of CERN, where the boundaries of human knowledge are constantly pushed, a revelation has arisen that sends a shiver down the spine of even the most seasoned scientists. Brian Cox, a former scientist at CERN and a voice of understanding in the field of particle physics, has recently said something that has left the world both enthralled and uncomfortable. Cox's words resound with chilling clarity. The reason for CERN's Large Hadron Collider is to recreate a mini Big Bang. Yes, you heard that right, a small version of the very event that gave birth to our universe. The physicist also went on to explain the ramifications of this goal, highlighting the LHC's great potential for making new discoveries. This includes its potential to uncover the secrets of the Higgs boson and investigate dark matter, a mysterious substance that makes up a sizable part of the universe. Imagine holding the strength of creation in your hands, possessing the power to summon the very essence of the universe. An attractive possibility, but one fraught with risk. The mini Big Bang isn't just a theoretical idea, it's a completely real phenomenon within the LHC. The temperatures, the pressures, the raw energy, all of it recreates the conditions of the universe's start. It's like standing at the dawn of recorded history, witnessing the beginning of existence itself. But with such power comes responsibility, and the question looms, what if something goes wrong? In fact, something did go wrong. Back in 1978, Russian physicist Anatoly Bugorsky encountered a catastrophe that would forever change the course of his life. While working at the U-70 synchrotron at the Institute for High-Energy Physics in Protvino, Russia, a failure caused his head to accidentally enter the direct path of a proton beam. The beam, with a pressure that defies belief, passed through his skull, entering the back of his head and exiting through his nose. Bugorsky's experience was harrowing. He saw a flash brighter than 1,000 suns but had no immediate concerns. The beam's path left behind a burning trail of destruction, bone and tissue, but he remained conscious and even walked to the center for treatment. The result was both troubling and surreal. The beam caused localized tissue damage, leading to partial hearing loss in one ear. Bugorsky's facial paralysis was remarkable, but his cognitive abilities remained intact, and he continued to practice medicine. This incident serves as a reminder of the great energy and potential dangers of particle accelerators. The risks of particle smashes, such as the LHC, should not be underestimated. The potential for catastrophic reactions, the very fabric of life being altered, these aren't the stuff of science fiction, but real concerns voiced by respected scientists. One of the most unsettling and captivating issues associated with the LHC's experiments is the possibility of creating a miniature black hole. Black holes are areas of spacetime where gravity is so strong that not even light can escape. They are massive vacuum cleaners, devourers of stars, and enigmatic entities that lurk within the shadows of our universe. The fact that the LHC could potentially create one of these phenomena, even on a small scale, is awe-inspiring to both the public and scientists alike. Could this black hole eventually expand, emerge from control, and swallow the Earth from within? Scientists at CERN have reassured the public that any black hole created would be unstable and vanish without a trace. Nonetheless, the remote possibility has sparked debates, fears, and a sense of awe at the power we wield. It's important to understand how the LHC might create a black hole. The fundamentals are everything: the mechanics of particle accelerators. When protons are smashed together at nearly the speed of light, the energy produced is so immense that it distorts the fabric of spacetime itself. Imagine a trampoline stretched tight, then a heavy object dropped onto it. The fabric bends, and if the object is heavy enough, it can create a well so deep that anything nearby will be drawn into it. This is an analogy for what could happen in the LHC within the framework of quantum physics, where the laws of the universe are both strange and amazing. There's a hypothesis that more dimensions might be hidden within our reality. If these dimensions exist, the LHC's experiments could tap into them, creating a gravitational well that forms a small black hole. This peculiar dance of particles has even caught the attention of some respected scientists, notably, the late Stephen Hawking. In his book, This peculiar dance of particles has even caught the attention of some respected scientists, notably, the late Stephen Hawking. In his book Black Holes and Baby Universes, Hawking discussed the potential for mini black holes to be created under extreme conditions. He theorized that, if such black holes were formed, they would quickly evaporate due to a phenomenon known as Hawking radiation. Hawking reassured the scientific community and the public that these black holes would be minuscule, existing only for a fraction of a second before disappearing. However, despite these assurances, the idea of humanity tampering with forces of such magnitude continues to fuel debate and speculation. The concept of parallel dimensions adds yet another layer of mystery. Some physicists speculate that if extra dimensions exist, they might interact with our own in ways we don't yet fully understand. Could the LHC inadvertently create a bridge to another realm? Could the energies unleashed in these collisions open a door to unknown territories of physics, or even to realities beyond our own? Beyond theoretical concerns, the LHC has already led to tangible discoveries that reshape our understanding of the universe. In 2012, scientists at CERN confirmed the existence of the Higgs boson, a fundamental particle that gives mass to everything in the universe. This discovery validated the standard model of particle physics, a framework that describes how fundamental particles interact. But even as we celebrate these achievements, new mysteries emerge. Dark matter, which makes up approximately 85% of the universe's mass, remains elusive. The LHC is one of the most promising tools we have to detect it, yet so far, its existence remains inferred rather than directly observed. Could the next great breakthrough come from an unexpected discovery at CERN? With each experiment, we edge closer to understanding the fundamental forces that shape existence itself. However, as we unlock these secrets, we must also consider the ethical and philosophical implications. The pursuit of knowledge has always been a double-edged sword. Throughout history, scientific advancements have led to both profound enlightenment and unforeseen consequences. The LHC represents the pinnacle of human curiosity and ambition. It is a testament to our relentless desire to comprehend the universe. But as we peer into the abyss of the unknown, we must ask ourselves, how far should we go? What risks are acceptable in our quest for knowledge? As CERN continues its groundbreaking research, one thing is certain: our journey into the heart of the universe has only just begun. Scientists have warned of a scenario in which the Higgs boson could become risky at very high energy levels. This instability could cause a catastrophic event called vacuum decay, an event that wouldn't just destroy Earth but could potentially destroy the entire universe. The renowned English cosmologist and astrophysicist Sir Martin Rees also expressed concerns about the experiments carried out at CERN. In his book on the future, he explored the possibilities for mankind and the potential risks of particle smasher experiments, including those at CERN. His words weren't just cautious, they were filled with a sense of existential dread. He examined a worst-case scenario in which a failed experiment could trigger a phase transition that would ripple through the fabric of spacetime, resulting in a potentially disastrous event engulfing the entire universe. Ries's concerns were not confined to theoretical musings. While he assigned a low probability to these catastrophic outcomes, he argued that even a small risk warrants serious attention. The stakes are high, and the margin for error is razor-thin. Scientists at CERN have run simulations, analyzed theories, and taken every precaution to ensure the safety of the Large Hadron Collider, LHC. In fact, physicist Brian Cox has emphasized the importance of these measures. Acknowledging public concerns regarding the LHC's operations, he assured the general public that stringent safety procedures, thorough reviews, and meticulous processes are in place to ensure that all experiments are conducted with the highest degree of care. Cox reassured the public that the energy levels involved are well within what the Earth naturally experiences and that the chances of developing a stable black hole are extremely small. Even if one were to form, scientists claim it would be so tiny and unstable that it would dissipate quickly in an explosion of energy, as predicted by Stephen Hawking's theory of Hawking radiation. According to Hawking, such an event would be a fleeting moment of cosmic wonder, a short glimpse into the void, then gone. Some have taken these ideas even further, speculating that the LHC's experiments could provide a pathway to another universe or dimension. While mainstream science generally dismisses this idea, it has captivated the imagination of many and become a topic of intrigue, fear, and even myth. Could we accidentally unleash forces or entities that we do not understand? The concept of opening a door to hell has even been sensationalized in various media, fueling uncertainty. But how did this idea come about, and what does it mean in terms of scientific exploration? The concept of multiple dimensions is not new in physics. String theory, a major contender for a theory of everything, suggests that there could be more than the usual 3 spatial dimensions plus time. These additional dimensions might be compactified or hidden from our perception, but in theory, they could be accessed or discovered under extreme conditions. Now, consider the LHC as a massive key unlocking doors that have remained closed since the dawn of recorded history. When protons collide at energy levels never before achieved on Earth, they could, in theory, create ripples or waves that probe these hidden dimensions. If such dimensions exist, the LHC may indeed reveal them. However, before we indulge in wild speculation, it is important to remember that while the LHC is undoubtedly powerful, there is no definitive evidence suggesting it will open a door to another universe, let alone to hell itself. Still, the allure of the unknown, combined with the mysterious nature of quantum physics, ensures that such ideas will continue to captivate the public imagination. Should we be concerned about the LHC and its potential risks? It's easy to be swept away by sensational headlines and apocalyptic fears, but the reality is that CERN's scientists are highly aware of the dangers involved. They have taken every precaution to ensure their experiments are safe and continue to monitor and test their work with the utmost care. The potential advantages of this research are truly remarkable. Breakthroughs in our understanding of the universe, including the discovery of new particles and the exploration of dark matter, demonstrate human ingenuity and offer a window into the very heart of existence. However, like any great scientific advancement, this work comes with risks. We must approach it with a balance of wonder, respect, and caution. The Large Hadron Collider symbolizes the frontier of scientific inquiry, where theoretical physics meets experimental reality. Its potential to answer fundamental questions about the universe, such as the nature of mass, its origins, and the mysteries of dark matter, is immense. Yet, despite rigorous safety measures and extensive simulations, the LHC continues to evoke a sense of mystery and fear in some. Its sheer scale and the energies it generates are awe-inspiring, and each new experiment pushes us into uncharted scientific territory. While most scientists remain confident about the safety of LHC experiments, fundamental uncertainties remain. What if unexpected anomalies arise that challenge our understanding of physics and the very laws governing the universe? The LHC pushes the boundaries of human knowledge and, in doing so, tests the limits of our ability to control the natural world. As particles collide under conditions that have remained hidden since the Big Bang, these experiments highlight the significance of scientific exploration, while also raising existential concerns about our impact on the very fabric of the universe. Despite the fears and speculative theories, the LHC has already yielded groundbreaking discoveries, most notably the confirmation of the Higgs boson in 2012. This discovery was a milestone in particle physics, completing the Standard Model and deepening our understanding of how fundamental particles acquire mass. Yet, beyond the known physics, there remains a realm of possibilities that the LHC could unlock. One of the most intriguing aspects of modern physics is the search for dark matter, a mysterious, invisible substance that makes up roughly 27% of the universe's mass-energy content. Unlike ordinary matter, dark matter does not interact with electromagnetic forces, making it impossible to detect directly with traditional instruments. However, the LHC's high-energy collisions may produce exotic particles that provide clues about its nature. Furthermore, some physicists speculate that the LHC could uncover evidence of supersymmetry, a theoretical framework suggesting that every known particle has a heavier superpartner. If proven, supersymmetry could bridge the gap between quantum mechanics and general relativity, potentially leading us closer to a unified theory of physics. But the pursuit of knowledge always comes with risks. Some critics argue that the sheer scale of these experiments demands even greater caution. What if the collision of high-energy particles creates an unforeseen reaction, something beyond current scientific predictions? While the likelihood of a catastrophic event is considered infinitesimally small, the debate raises important ethical and philosophical questions. How far should humanity go in its quest to understand the universe? Are there boundaries we should not cross? These concerns are not new. Throughout history, scientific advancements have often been met with fear and resistance. When the first nuclear reactions were studied, some feared they might ignite the atmosphere. When the first particle accelerators were built, there were concerns about unforeseen consequences. Yet, time and time again, science has moved forward, carefully measuring risks against potential rewards. The LHC is no exception. Its experiments are meticulously designed, reviewed, and continuously assessed to ensure safety. Moreover, the energies involved, while immense by human standards, are still minuscule compared to cosmic events that occur naturally throughout the universe. Earth itself is bombarded by high-energy cosmic rays far more powerful than anything produced in the LHC, yet no catastrophic vacuum decay or universe-ending event has ever occurred. Ultimately, the Large Hadron Collider represents humanity's unyielding curiosity, our desire to peel back the layers of reality and uncover the deepest truths of existence. Whether it leads to revolutionary discoveries or merely refines existing theories, its importance cannot be overstated. It is a testament to human ingenuity, a monument to our collective pursuit of knowledge, and a reminder that, even in the face of uncertainty, the quest for understanding must go on. As new experiments and upgrades push the LHC to even greater energy levels, the questions it seeks to answer will only become more profound. What lies beyond the standard model? Could we one day glimpse into extra dimensions or uncover the very fabric of space-time itself? Only time will tell, but one thing is certain: the LHC has already changed the way we see the universe, and its journey is far from over.